welcome to Atlassian. I'm Ryan, I work at Facebook. I'm here to talk about scaling Material, both systems and the user experience. So let's jump right in. I have a bunch of slides I made earlier today. This is my first time doing the presentation, so let's see how it goes. Feel free to interrupt me with questions, okay? All right. So the first thing to realize about this is that I can't see my slides up here, so I'm going to be looking back here a lot. And the second thing is that at Facebook, our setup is really big. We have hundreds of thousands of files, hundreds of thousands of commits, thousands of engineers cloning this, pulling from it, and committing changes. And the existing tools we had were really not scaling at all. There are problems with repository maintenance, there's push contention, and in the middle of those two things, there's the single master. So we just had problems with any time that a box would have trouble, which happens a lot when you're working at large scale, you're going to have problems with the single master going down, and you won't be able to have anyone making commits for a while. You have to do a failover, everybody notices, they complain, all that kind of stuff, okay? So let's go through these problems and the solutions we come up with for them, okay? I really wish this worked. Hang on, let me see if I can. All right, let's not. Okay. One of the things when you have a bunch of files is that just checking simple things like a status call to each file in the repository, that's really expensive. When you're building things, you have to go and find all the files that change to see what you need to build. So just checking the dependencies of what you need to build, that can be very expensive as well. When you're using the traditional way of doing this, which is asking the file system for every single file, when was the last time you changed, what's the size of your file, basically statting every file. When you have hundreds of thousands of files, this can take seconds. When your cache is hot, when everything is in memory, it takes seconds. If you're having to read things off of disk, it takes minutes. Literally, after you start up and you do this for the first time, you do HT status and you go and you grab breakfast with your friends, right? Like, it takes a long time. So what we did is we built a program called Watchman. What Watchman is basically an abstraction layer on top of things like iNotify in Linux and FS events in OS X, which gives you a list of all the files that you're interested in that have changed since the last time you asked for it to sync, basically, okay? A big contributor is actually sitting right here, kind of a celebrity in these parts. And the big thing here is that instead of taking seconds to do this calculation, we get answers in milliseconds instead. And I guess I'm still supposed to hold this, even though it's not bouncing off everywhere. For the people who are watching it later. Okay. So, this actually works. We've been using it at Facebook for a couple of years now, and the difference is really dramatic. So if you look over here at this graph where the bottom is actually 0, it's not a misleading graph. When you use HG with HG Watchman, compare that to Git on the same repository, the same size, you're seeing dramatic improvements in the time it takes to do a status call, okay? And that really matters to people. The difference between here and here, we're talking half a second to 4 or 5 seconds, okay? And 4 or 5 seconds, anything that takes that long is like I'm going to Alt-Tab and I'm going to go be looking at Facebook. And I'm actually going to be wasting 10 minutes instead of 5 seconds, okay? If it comes back in half a second, though, I stay on task and I just switch, I do the status and I make my commit and so on, right? Like it really makes a big difference. So the other thing is that the checks stay constant time even as your repository grows. So if you have 100,000 files or 1,000,000 files, you still have the same constant time check, and that's actually a really important thing. It affects more than just status though. Things like diff and checkout and commit are also sped up by this because basically they have to do status calls in order to figure out what each of these things are going to do, right? Diff's a little bit faster overall because diff only ever has to look at tracked files, so it's more obvious which ones to look at, whereas status has to look at your entire working directory. But the other things are also sped up, so this actually has a pretty dramatic effect across the board. Another thing that we do when you have a bunch of files is most of the time those files are not actually all important to you, right? If you're working on a single project, you might not need all the other subdirectories in your repository because you're only building things in this one directory. And so we have another extension called the Sparse extension, which allows you to have a sparse checkout, only check out the files that you care about at any given time. It also speeds up things like status and diff and so on because, once again, there are fewer files to check. The way to use the Sparse extension is basically you have profiles that your build system can be keeping up to date for you. So you don't have to do any manual curation of them. If you start relying on something new or somebody else starts relying on something new, that will automatically be updated for you. And so that's really nice. It means that it's very automated. And it's open source. You can go grab this and start using it yourself if you want. Okay. Another problem is that we have a very large and very quickly growing commit history. So we have hundreds of thousands of commits in our largest repositories, and we're getting thousands more per day. So this has a couple of things. One, that it means that your clones are going to be really slow. When you get a new copy, you have all of this history that you have to download, and all of the file history that each of those things. So that basically means when you do a clone, you have to be copying gigabytes of data, which takes a long time, even in fast networks. Checkouts are also slow, because anytime that you're pulling all of these changes in, you have to be changing a bunch of files. It also requires a lot of disk space that you're generally not going to use. You're never going to go back to the version of Facebook that existed in 2007, as a part of your regular job at least, right? So you don't need all that history most of the time, right? Most of the time you only need the stuff you're actually working on right now, the most recent stuff. This affects both developers and the infrastructure. Just the size of things, actually affects how many repositories you can have on a build server, for example. If you have a 50 gigabyte repository versus a 1 gigabyte repository, you can really see how that would affect things. So what we have is something called remote file log. What remote file log does is, instead of storing everything locally, like a fully distributed version control system, we more intelligently choose the things that we're going to store locally. Let me go over what this looks like. This is a normal setup for a distributed source control system like Material. This is Material, in fact. We have our change log, which has all of our commits. Then for each file, we have all the different versions in what are called file logs in Material. Okay? When we do a clone, we get all of a copy of that locally. So we have all of that same data, gigabytes of data. What remote file log does is when you do the clone, all you get is the change log. Technically also the manifest, but I'm ignoring some details here. And when you just get that, you ignore all this stuff, which is the vast majority of the data. It's about, in our repository today, it's about 1/50th. So this stuff here will be about a gigabyte. All that other stuff is 49 gigabytes that you no longer need to download. So clones are blazing fast compared to anything else, right? And then on demand, as you need the particular versions, we download those as well, okay? But you only have those latest versions of each file. You don't need to have all of their context, and that actually makes a really big difference. Once again, let's look at some graphs that are nice and pretty. P75 time for rebase, significantly improved, about half the time. P90 pull, hugely improved. And you look at clone, and we're talking like, this is like a go get breakfast versus like maybe I'll do work today kind of thing, right? Here's another really big effect it had. This is the network I/O on one of our Material master servers. When we started rolling out remote file log, we were doing a bunch of I/O. And when we finished the rollout, it was about 10x lower, because once again, we don't have to download all this data that people are never going to use anyway. So it makes a really big effect. It's actually really nice. So the overall advantages we went over: much faster pulls and clones. The scale just is more, the server is more scalable simply because you don't have to download all the data all the time. The main downside is that it's optimized for an always online environment. If you have a laptop running, you're going to be offline a lot. There will be times where you want to do something and you can't because you need to download more stuff from the server. We try to intelligently cache stuff, but we don't guarantee you'll be able to do any operation. So, the third problem, push contention. This is probably one that you're like, what does that mean? What does push contention mean? Well, when you have thousands of engineers, and they've been writing code all day, and they get to be about 3 or 4 o'clock, and they want to start pushing that code. It's been approved, it's been reviewed, all that stuff, and they want to start pushing it to the server. And you're running with something like Git or Material, which requires that the things you push have to be on top. We don't want to have a branchy repository. We want everything to appear linear, so we do a rebase-based workflow. If you have 2 clients and they're both trying to push, they both are up to date, and they're both trying to push, one of them will win and the other will lose. So what client B does is it tries to push and it loses this race. And it has to go and has to pull from the server. rebase its changes on top of that new thing it pulled, and then try to push again, and it might lose again. And so we actually have many servers at Facebook doing this in loops for developers, so they don't have to be doing it themselves, and it's kind of a mess, right? During the peak times, we actually are smearing these changes, like the peak push contention happens, what, around 3 o'clock or so? That's when everyone wants to get their stuff in. And we actually smear these changes out over a long time, and it might take an hour for your stuff to get in, right? Like, it's really crazy, with just because it takes so long to get these changes in. So what we did at Facebook is we developed an extension called Push Rebase. In one of the rare times where I say something was inspired by SVN, this was inspired by SVN, and it's a good thing, right? Basically, in SVN, you can always push something as long as the particular files that you're touching haven't been touched in between when you last updated and when you push. Push Rebase basically does the same thing for you. It will rebase on the server for you, and as long as there isn't a conflict, your changes will land. And that's really nice. It means that you're in the situation again where both are pushing at the same time. One wins, but the other one also wins because this change is going as well. Everybody's happy, right? So you get both changes in there in some order that the server will define, and you get your changes in. And so once again, this is an open source thing. You can go check it out. It's in our Mercurial experimental extensions repository. That's on Bitbucket. Go Bitbucket, yay. It increases the throughput that you'll actually see. It also reduces frustration. That's a really big one, is to reduce frustration. Because people can make scripts that do this, and we can write a bunch of code. Sid mostly can write a bunch of code that will make sure this stuff keeps happening. But it's really nice when your stuff goes in right away as opposed to an hour from when you thought it was, right? So there we go. Another problem that we run into with large-scale deployments of source control is server administration. So Git at scale has a few problems. There is one really nice thing. It has this atomic pushes. So like when you do a push, all your stuff goes in or none of it goes in, right? That's also a downside if you're doing this since you don't have the rebasing on the server side. But it has a bunch of cons. It requires that you have a single master. So there's one source of truth. That means that basically you have to throw a pretty big box at that. And there's some other issues. It has garbage collection, so once a day we run garbage collection, and you can't push for that hour or whatever. And we try to put it at the least likely time people are going to commit. But we now have people in London and people in New York and people in Seattle and Menlo Park, and so people are pushing a lot of time around the clock. And so it gets harder and harder to find good times to do garbage collection. Another thing that Git has is when you're trying to calculate the difference between what the server has and what you have locally, that's a relatively slow process to go through all of the objects that exist and do some extensive calculations. And then it has to repack all of those things that are different to upload them to you. So each of these things is expensive and takes a long time. So we actually, in the real world, see long-running upload packs that take an hour or more. So Mercurial at scale has a few more pros. The difference discovery is relatively fast. We don't have to do any of this repacking stuff, and there's no garbage collection. However, there's a few issues, and there's one more. Whoops. Okay. Maybe there's not. These are all the issues in the world. Okay. But it was for a long time missing the atomic push functionality. So basically, this would be the problem where you push some commits, and then you would say, now I'm going to push a bookmark to point at those commits, but maybe somebody else pushed in the meantime, and now your bookmark's not pointing at the place you expected anymore, which would be the tip of the things. This was fixed in core by the Bundle 2 rollout, which Period is largely responsible for. You also have the single master problem. So core, basic Mercurial still requires that there be a single master that is the source of truth. And at Facebook, what we've done is we've solved this with the HGSQL extension, and I'll talk about that a little bit here. So here's a typical single master setup. You have all of your clients, they talk to a single server, it is the source of truth, it defines what goes in. If it goes down, you have to do a failover, and nobody can talk to Mercurial in the meantime, or nobody can at least land anything. You might maybe have a read-only tier, which is what we do in Git. What we do with HGSQL is we actually set up multiple servers. 3 is actually the number we have. And they synchronize through a MySQL database. And what this allows is that a single server can go down, and nobody notices. We don't even notice half the time. Like there's some alarms which we put into some folder that we look at every once in a while, and like, oh, the server's down, let's bring up a new one, or let's reboot it, or whatever. And it doesn't matter, nobody notices. this literally makes it so that our administration is much easier. We did failovers of our SVN stuff, and it didn't go super smoothly. There were some troubles, and it took like all of us in a room for half the day to do it. And then we did the same thing for Git, and some things went wrong, and it was a mess, and we had to do cleanup the next day. And then we did it for Material, and I was sick, so I didn't even show up, and nothing happened. Nobody noticed. It was like the most amazing thing. It's really simple because we had this setup where we could just very easily transition over, and nobody knew that it was going on except that we told them, right? So that's really nice. So, sort of the fifth problem that happens at scale is actually not a systems problem so much, but it's more of a user experience problem. When you have thousands of people that are not familiar with a workflow, you end up finding all the rough edges of a UI, of a user experience. So I want to go over some of them. So one of the philosophies we have is that source control is a tool. I happen to fall in love with source control when I first started using it and being like, oh, this is really cool, I want to learn everything I can about it. But a lot of people don't do that. A lot of people have their expertise, and it might be in AI, or it might be in building cool apps, or whatever it is. And to them, they just want to save their code, and they don't want to think about how it works. They just want it to work for them, right? And so we don't want everybody, not everybody wants to be an expert, and we don't think everybody should have to be an expert to get stuff done. And distributed source control systems tend to be very powerful, but that power also comes with a lot of complexity. So let's go over some of the ways that we tried to file off some of the rough edges of Material. So here are some questions, which if you ask them to Material developers, you'll get different answers for probably, because they're actually fairly complex. So HT update, what does it do? Well, the main thing it does is it pulls in new changes, but it also will move your bookmarks around sometimes in certain weird ways, and it sometimes won't move a bookmark locally, and there's like some confusing things that can happen. And if you aren't careful, then you end up like you actually have to describe a few things that happen. Oh, that's HT pull, but HT update also sometimes moves your bookmarks, sometimes it doesn't. Sometimes it activates them, sometimes it deactivates them. Sometimes it does a merge in your working directory. Like there's all these things it can do, and it's really confusing if you don't know exactly how to use it. HT log is another thing. It shows you the log for your entire history, not just where you are, and that confuses a lot of people. HT rebase, if you run it without any arguments, it does something, and most people don't know what that is. So there's a lot of these little rough edges. So what we did is we have an extension called tweak defaults, and what it does is it just tries to round out some of these corners. So for example, update now requires a destination. It also implies -- check, so it will never do that merge thing that you didn't expect unless you tell it to. It will never move things around that you didn't tell it to. It requires that you actually tell it what you want it to do so the behavior is explicit. HT log, we change it so it implicitly gets a -- follow, which is sort of the behavior more people expect. What is the log from where I am? If you want the entire log, you can tell it to give that to you via -- all flag that we added. But that's sort of a more intuitive behavior for that. And HT rebase, like update, also now requires a destination. We also created working with Sean, actually, Sean created an extension called remote names based on Augie's remote branches extension, and then I helped complete that and get it so that it's deployed in Facebook. And what it does is it rounds out some of the sharp edges around the bookmarks workflows. So bookmarks are basically a way of saying, here's a pretty name for a particular commit. They do some weird things on push and pull if you don't know precisely what they do or if you get a little confused. And so what remote names does is it rounds out these edges, and now you actually know exactly what's on the server and what's local, and you tell them when to interact instead of having them interact at inopportune times when you didn't expect. That's also open source. It's on Bitbucket under Sean's thing. That's the source of truth. It's under HT remote names. You can go download that as well. There's also the problem that in a repository where you're doing multiple things at once, which we encourage at Facebook, having multiple heads that you're working on at any given time, it can be hard to understand what you're working on and how the different changes relate to each other. You can use HT log or HT heads, but that's really insufficient. It doesn't give you a great picture of what's going on. You can use HT log with -- graph, which is a lot better. It gives you a much better picture of what's going on, but it also shows you a lot of stuff you don't care about. Maybe there's a bunch of intermediate commits. Remember, we have a really high commit rate, so there might be 1,000 over the course of the day. If you come back and there's 1,000 more commits, you have to scroll through before you see your stuff. That's really annoying. So we want to show you only the commits you're interested in, but keep the nice parts of the graph you have and hide everything else. So what we have is something called HT Smart Log. It's a useful extension that basically does exactly that. It shows you the stuff you're interested in, hides the stuff you don't care about. Here's an actual output of Smart Log in a repository with a bunch of test bookmarks I made. So you can see it shows you this thing, Remote Master, that's a remote bookmark from the Remote Names extension. It shows you different bookmarks you're interested in. It shows you how they're related to each other via a graph. And it's really nice. And once again, it's open source. You can go download it from our experimental extensions repository. And the final thing that a lot of people complained about and that we found ourselves spending a lot of time helping people with was how to recover changes when they're lost. So by lost, I mean maybe you amend something and you realize that you made a mistake and you actually want the old version back. Or you do a rebase and you realize, I wish I hadn't done that. That kind of thing, right? So when you've lost a change, how do you get it back? Material is really safe in that you'll never actually lose a change. Once you've committed it, it's safe, it will be, and if it's removed, it'll actually be moved to a backup bundle, so it's not in your repository, but you can get it back. But recovering the changes are actually a fairly involved process. You have to look inside of each backup bundle to see what it has, and you have to find the right one, and then restore it, and then you might have to do some changes to your bookmarks, get the bookmarks restored to where they wanted to be, and that kind of thing. So it can actually be fairly involved. And so what we did is we created an extension called reflog, which will be moved into Core and called journal, so I'm calling it journal here, and another extension called reset. And basically what the journal does is it keeps track of everywhere that your bookmark's pointed and everywhere that your working copy pointed. So if there's a particular hash that a bookmark was pointed at, it'll keep track of that. And if it ever moves, it'll keep track of that change as well. It'll also keep track of what command caused it to move. And so you can go and open a UI and it'll show you this command caused this bookmark to move here, and that kind of thing, right? And then you use that in conjunction with reset. So this is a really quick way to find out what hash do you want. And then reset knows how to look inside the backup bundles and recover the right backup bundle. And then move your working copy and optionally a bookmark to point at that new place. And then do some cleanup after you. And again, this is both of these extensions are available. And journal will be moving into Core before too long. And finally, we're working on something at Facebook, and even before Gary came to Facebook, he's been working on this for a while, called change set evolution, which will, instead of deleting the commits out of your history and moving them to the backup bundle, it'll just hide them. And that will be really nice because recovery will be even easier. Those commits will still be in your repository. You can use normal commands to interact with them, and you can pull them out. And then sort of the next step is that we'll put really fail-safe, easy-to-use UIs around this, like commands around this, that will make it so you can, even people who aren't familiar with source control should be able to safely recover their changes in a way that makes sense and makes it easy for them to do that. And again, open source, you can go download it, you can contribute to it, all that kind of stuff. And so one really big theme that you've probably seen is everything that we're doing here is open source. You can go download it, you can use it yourself, you can contribute to it if there's anything you don't like about it or want to see changed, and we'd love for you to do that. You can get involved in the community, it's really easy. Probably a lot of you here are already involved, so thank you. But anyone else that wants to jump in, go over to the wiki, join us in IRC and Found Material, and we'd be happy to talk to you and help you make your first change. All right, that's all I got.